So this is Chapter 7, Video 4, all about triangles. It goes with Section 7.3, but also 7.3 extension in your book. So in this one, we're going to classify triangles. So we're going to categorize them, sort them, based on a couple different things. And we're also going to construct or draw triangles to fit different conditions, and then solve some problems with triangles. So write these targets down. Make sure you have them both copied on your notes. Here we go. So what is a triangle? You'll recognize that all these pictures up here are triangles, but they all look a little different. A triangle is a shape that has three straight sides. Okay. A lot of times I'm going to ask you to measure and label the side length. So when we do that, it might look something like this. Maybe it's centimeters or inches that you measure. So it has three sides. It has three vertices, right? Three corners or three tips to it where the three sides meet. And it also has inside those vertices three angles. So we're going to also be able to measure and label the angles of a triangle like this. So let's talk about the different types. You can classify a triangle a couple different ways. The first way is by angles. And this needs to be written in your notes. You have a spot to write 1, 2, 3, and the 4 ways to classify by angles. Let's go through them. First one is acute. An acute triangle has all acute angles. So all three angles are less than 90. An obtuse triangle has one angle that's bigger than 90. If it has one that's bigger than 90, that makes it obtuse. If it has an angle that's exactly 90 degrees, we call it a right triangle. It has one right angle. And if all three angles are the same, they're all the equal measurement, or all congruent, then it's an equiangular triangle. So pause if you need to. Make sure you have these pictures and definitions and words all written down in your notes. Okay, we can also classify based on the sides of a triangle. Okay, remember congruent means same length. So a scalene triangle has none of the sides the same length. They're all three different. Isosceles triangle has two sides that are the same length, and we mark that with these little dashes through the sides. So if you see that, that's going to be an isosceles triangle. It means this side and this side are the same length. And then equilateral, all three sides are the same length. So this and this and this are all congruent. Okay, so that's a total of 7 different words that you should have written down with pictures and definitions of how to classify triangles. So let's classify these. Classify means give me the group or the category that it goes into. You know, what words would we use to describe it? So number 1, I notice these marks right here, and I see that these two angles are the same. Well, if these two sides are the same length, I know it's isosceles. And I also see 70, 70, and 40. Those are all acute angles. So it would also be an acute triangle. Okay, number 2, I have a right angle here. That's easy to spot right away, so I know it's a right triangle. And then it looks like I have markings here that tell me that these two sides are the same, so that makes it isosceles. Okay, I'll do one more and then you can do 4, 5, and 6. All right, so it looks like I have all 3 different angle measurements, which makes all of the sides different lengths. So that's going to be scalene. None of the sides are congruent. And I also see an obtuse angle right there, the 104 degrees. So obtuse and scalene. All right, so you try 4, 5, and 6. I know that the angles are a little hard to read, but try those and we'll check. Okay, number 4, it looks like I have an obtuse angle and 2 sides that are congruent, 2 angles that match as well. So obtuse and isosceles. Number 5, I see a right angle right here, and I also see 3 different angles, 3 different side lengths, so right and scalene. And then it looks like I have markings here that tell me I have 3 sides the same, and 60, 60, 60, 3 angles the same, so equiangular and equilateral. Okay, so how to draw different triangles. I know you might not have a protractor, maybe you're copying this down as best you can in your notes, but at least show me what the pictures look like, maybe write down some steps so that you'll have a better idea when we try to start doing this together in class. Okay, so to start with a right triangle, because I need a right isosceles triangle, I need a right angle. So I'm going to put my vertex on my line here. I'm going to move my protractor over and line it up. Find 90 degrees and make a little mark. Move my protractor back out of the way and connect those with a straight line. So there's my right angle. Got that. And then I need isosceles, and isosceles means I have to have two sides the same length. So if I had a ruler, let me see if I can add one. Okay, this isn't going to be perfect, but I'm going to use my ruler here to measure maybe 4 centimeters, put a little mark, and then, yep, I can't get it to turn. So I would turn my ruler and also measure 4 centimeters up this way and put a mark. So it would be something like this, and then I just need to connect those two together, and there's my isosceles right triangle. Be sure you mark it with the dashes to say those two are the same length. Okay? All right, how about B? Obtuse and scalene. So let's start with an obtuse angle. I already have, let's put a line here. Okay, there's my line. Going to put a vertex on it. Let's put, actually I'm going to make it flat. There's my vertex. Okay, I need an obtuse angle. So anything bigger than 90, let's say 110 right here, might work. That's obtuse. So connect those with a straight line. That's not very straight. Connect those with a straight line. So here's my 110 degrees. And then scalene, just 3 different lengths. So nothing has to be special, nothing has to be the same length. I just have to connect it and make a scalene triangle. So something like that, where this side and this side and this side are all different lengths, and it's obtuse. Okay, so let's try a couple more. You're just following along, sketching these as best you can with us. Okay, triangle with 3 centimeters and 4 centimeters that meet at 20 degrees. Well, let's do 20 degrees first. I always have to start with a line. Put a vertex on it. Let me get my protractor back. I'm going to measure 20 degrees. Put a dot, move it back out of the way. Connect those with the line. I'm going to make it extra long to kind of fit. And then I would measure. I need 3 centimeters and 4 centimeters. Okay. So I'd get my ruler back out. You'll have a ruler to use in class. Let's measure 3 centimeters. And then 4 centimeters. And then connect those. So there's your triangle. I've got 20 degrees, 3 centimeters, 4 centimeters. Looks something like that. Okay. Last one. Triangle with angle measures of 30, 60, and 90. And then classify it. Ooh, we forgot to classify this first one. Well, looks like I have an obtuse angle here. And I think they're all going to be different lengths, so scalene. All right. Last one to draw. 30, 60, and 90. All right, start with a straight line. Put a vertex on it. Doesn't matter which one you want to do first. Let's do 30. So move my protractor down. 30 degrees would be here. Move it out of the way. So let's connect those. Okay. So label it. Then I need 60 and 90. Again, doesn't matter. Let's just, 90 is probably pretty easy. If I put another vertex on there and draw 90, it would be straight up to there. Straight line. And that should be good. There's my 90. And by default, just because that's what's left, that should be 60. Okay. Classify it. Well, it's definitely right. And then all 3 sides are different, so scalene. Okay, so I hope you can copy these down. I know you don't have a protractor, but at least you'll have something to look back on, and you kind of have an idea of how to get started when we practice this together in class. Okay, so now I want to talk about the angles of triangles. Angles of triangles always add up to 180 degrees. Write that down. I'm going to prove it to you. So here's a triangle. Okay, it has 3 different angles, red, blue, and green. If I take that triangle and I copy it, and I rotate it like this, Okay, so there's the same triangle turned upside down there, and I slide it in here. It fits very nicely right there. Then I'm going to do it again. So right now I have a blue and a green. I'm going to rotate this one again, so I have a red angle like that. And I'm going to slide it in right here. And you'll notice that I have right here a red and a blue and a green. And those angles, when I put them together, they make this perfectly straight line that was there. So when we get a perfectly straight line, we know that's 180 degrees. So I just took the red, the green, and the blue angles, and I showed you that when I put them together, it makes a straight line, makes 180 degrees. Okay, so we're going to use that in these next couple examples. Does this make a triangle? Well, the only thing to check is see if it adds up to 180 degrees. So take your calculator, add these numbers real quick, see what you get. Okay, when I add these up, I get 180. So yes, if those were the three angles of my triangle, it would make a triangle. Next one, 33, 140, and 12. If I add those up, I get this number. If that's not 180, then it is not going to make a triangle. That's going to make some shape that doesn't quite connect or something that doesn't make a good triangle. Okay? All right, you're also going to see questions that say find the value of x. Here's how to work these out. I'm going to do a couple together. I see my three angles, and I know they have to add up to 180. So I'm going to write an equation. The 28 plus the x plus the 50 has to make 180 in order for this to be a triangle, which it is. And then I solve for x. Okay, so I can see that 28 and 50, that's going to give me 78. And I just have to get x by itself. So minus 78 from both sides. And I get that x is equal to 102. Okay, so for all of these, you're going to set up an equation, solve for the variable. This one looks like I have 90 degrees, 45 degrees, and x, and that has to add up to 180. So write out this equation, combine your like terms, solve for x, get x by itself. So cancel things out until x is alone. And I get, what, 45. Okay? So the rest of these examples, you're just going to use the fact that every triangle adds up to 180 to then work it out and solve for what the missing angle would have to be to make that true. So here is an example with a pizza slice. Looks like I have two angles here that are both x. Well, x plus another x makes 2x. And again here I have two x's. So again I have 2x plus 60 degrees would have to equal 180. So pause and solve those and work out and see what x would be. Okay, I've just finished the work here of getting x by itself. Right? Cancel things out until x is alone. X would be 54. So 54, 54, and 72 makes 180. Or in this one, I got x to be 60. So 60, 60, and 60 make 180. Okay? So you're going to try the next. There's 2 and 2, so 4 more questions total for you to try. Pause, set it up, solve, and we'll come back and check. Okay, in the first one, I wrote down my three angles that add up together equal to 180. Show the steps. You have to have all this work on your paper. Cancel things out until you get x by itself. So this would be 58. Same thing over here. Three angles add up to make 180. Combine your like terms, then cancel things out until you get x alone. Okay, 2 more to check. Let's do these. So pause, do them, and we'll check. Okay, always start with your three angles. 1, 2, 3 equals 180. And here, 1, 2, and 3 angles added together make 180. Look for any like terms to combine. X and x makes 2x. Same thing here. I get 2x. Just bring everything else down. And then work to cancel out until you get the variable by itself. So this is chapter 3 stuff. Cancel, 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 cancel. X is 26. or cancel, cancel, and x is 60.